In this video, I had a small technical glitch with my microphone, and in the next video as well, and so I had to dub over the entire video with my voice because it didn't record. So if you see things look a little bit out of sync from time to time with what I'm saying and what's going on is there, but I fully explain the code as we build it, and so that's why that's why there might be a little bit of technical desyncing from my voice and what's happening on the screen. So thanks, and here's the video. All right, welcome back to LagDemon Programming. In our last video, we set up our dungeon processor that processed a text file that explained how the dungeon should be laid out and turned that into a series of objects that can be used by our game. In this video, we're going to take that and tie that into our command processor so that the player can actually walk around in the dungeon, move around in the dungeon. We can create commands. The way we're going to do that is taking that object and putting it in as part of the context and how the system works. A couple little things I want to point out. We're going to have to make a player object, and we're going to also have to make that player object able to be shifted around inside the dungeon. And so the way we're going to do that is by tracking some information about that player. And that player is going to be tracking the name of the player plus the dungeon. Oh yeah, and we're going with C++ 17 because of a particular construct that I want to use. And that construct is a pattern matcher for tuples. That it makes it easy to extract information from a tuple without having to call methods on the tuple, and so forth. So, so we're going to make a player. That player is going to track the name of the player, the current room the player is in, and any list of items the player has. And we'll certainly get as far as we can in this video. We should be able to at least get things working. Here's how we use the pattern matching right here with the result of the compiler and the actual dungeon that comes back, and then we can check those values to see if everything's valid and take appropriate action. So so that's just a real simple, neat thing they added to C++ 17 is this pattern matching, among other things. There's more in C++ 17, but that's why I wanted to use it here. It just makes it a little easier to work with tuples. So up here in the, we're already getting our dungeon in our command processor, our command line processor. So I believe we set that up in a previous video so that it would start the command processor, pass in the dungeon, and so forth. So let's, we'll start in here. So first thing we're going to do is create a player class. We'll create a header file here, and we'll set up the, of course, the defines to prevent multiple inclusion, which we always do. And then we'll go ahead and start putting that class together. So what's a player? Well, a player in our case is really just a name and a location and a list of items that they possess. Also, we'll make this make these values here protected so that we can make other types of so that we can make other kinds of characters, like we might have a moderator character, and so that moderator character might have other privileges. We can derive it from player, and they still have all the player capabilities, but some additional capabilities and so forth. So we'll leave that for the future, perhaps when we get some sort of multiplayer thing going, if we decide to do that. I don't know. Multi-threading is something that's part of, kind of a separate thing, maybe a separate course, or maybe we'll do a separate playlist and continue on with this game and do multi-threaded. So here we've got the player name, the current room name, and the list of items that the player currently has, and we'll use commands to process these and make changes. And the player will be ultimately part of the context. And so this tuple contains an int and a string, and the string is just the ID of the item you possess. The int that goes with it is the quantity of those items that you have. Just a very simple way to do it using a tuple. So a vector of tuples in this case. All right, so now this is so I just copy pasted this in rather than typing it. It's pretty straightforward. It's just a finder function that zips through our vector looking for items. When it finds the item ID, it returns a tuple, but it returns a little bit different tuple. It's got two ints. The first int is the index of where it was in the vector, and the second int is the quantity, and the third int is the ID of the item that it found. Otherwise, it returns -1, a -1, and a space. We can detect that and say, well, there's no item if we get that -1, -1, and no, or not a space, but rather an empty string for the ID. Yep. So there's the -1 and the -1. So that's how that function works. So now we need to set up to create a player. And here I'll just copy paste this in. We're going to get a player name and a start room, and then just set those values, and we're good to go. And then just a few there's just a few basic functions, getters and updaters, things to add and remove items and so forth. And I'll just copy paste those in for my previous work rather than typing them all out. It's pretty basic stuff. We've seen it before, and you should pretty much know how to do that in C++. So here's the here's the basic methods. So we get the current name, we get the get the current room rather, get the player name, and add and remove items from the player. So that's pretty much a player class. Yeah, adding items is just a matter of, so this is where we take advantage of that being able to find an item. So we look and we find an item. If it's there, we're going to just increase its quantity by 1. If it's not there, then we'll just set a new one. And when we remove items just below that, we're just going to reduce the quantity by 1 if it's found. If it's not found, or if the quantity is 0, we're just going to leave it alone because you can't remove an item. But we'll leave it in place, and here's the remove item down here. We'll just remove 1 from the quantity and push it back in to the same index location. So it'll just stay there as an item if you have 0 of them, but it'll be kind of like a slot for that item at that point, and we'll find it in the future and increase it if you've got one. So. And so here's just a simple friend function. It's an operator, a stream operator, and we just put out the player name and items and list all the items that the players got with their quantity. Just a quick and easy way to dump a player out to the screen. So here we are in the command line section where we process a command line, and we're already getting the information, the dungeon up here. So now we need to just fill in the context appropriately. So we've got to create a player first of all. Well, we've actually got to get the player name first. I forgot about this. So what we've got to do is get the player name from the user. So what we'll do is we'll create a second little prompt here. When you start the game, it'll ask you for your player name that you want to use. So just say enter your name, or enter your player name. Enter your player name. And we'll just end that line, and then what we got to do is flush the standard out so that it's like a prompt, right, where you type it after the words. That's all that's for. Very standard stuff. We'll just put a colon and a space on the end to make it look a little bit better. And then we can just go, we can reuse our function that we've got for reading a line here. And we just say player equals read line. And it'll get that. Excuse me, that's got to be player name. There we go, player name. Okay, so now we've got a player and we've got a dungeon. Or we've got a player name anyway. We need to create our player. Now, I'm hard coding in the start room for the moment. One of the things we didn't add to our language was a way to tell it what the start room is. And we need to do that. We'll do that in a future video. We won't bother with it in this video. But in a future video, we'll figure out how to make our language be able to tell us what the start room is and store that so that we can start the player off in the proper room. Right now, I'm just going to hard code in lobby as the start room for the player. And we'll fix that in a future video. Actually, probably in the next video. But for now, I just want to get this basically working before we go in and mess with our language stuff again. So here's our context. And our context just a container with some data in it. So I didn't have to worry too much about, or didn't want to worry about getters and setters and all that. So I'm just making some public fields on this, sort of like a record. Because the only thing that's going to really be working with it here is our command structure. So so here's the context, and what we'll do is we got to include memory in this. So I'm going to use here a shared pointer. Yeah, I'm going to use a shared pointer in this. And what a shared pointer is a way of, if you're not familiar with them, it's a way of controlling a pointer so that when all references counting is done with this, and when it falls out of its reference, it deletes the pointer for you automatically. So it's nice to clean that up and carry it around in a secure way, because we'll be passing these pointers around a fair amount, and it's a good way to prevent issues with pointers. So what we're putting in here is a shared pointer to our dungeon and a shared pointer to our player, so that our context always knows those two things. That's the two game states that are important, the dungeon and the player. And of course, whether it's running or not is in there as well. All right, so now we can make up our player and our context properly. So we've already got a context, and the dungeon needs to equal the there's a couple ways you can make a shared pointer, and in this case here, with our dungeon's already a pointer. So I think we'll try it. Yeah, shared pointer. Yeah. So because the dungeon's already a pointer, we just want to create a shared pointer and pass in the dungeon. But we haven't created our player yet, so we're going to do the player a little bit different. We're going to say context.player equals standard, and we're going to use make shared. And make shared is a function that lets us pass in the values that we want to make that we want to use to make up this new pointer for a player, and we can just pass it in, and it'll call the constructor properly. We have a little issue here, though. I'm not sure what's that standard make pointer. I'm not sure what that. Oh, you know what? I know what it is. Let me check. Let me try to build it and see if this is an IntelliSense problem or an actually compile problem. Yeah, no, it's an actual compile problem. Let me check my notes here and see what I'm doing wrong. It's probably something simple that I'm just not seeing. I already built all this stuff, so it really should be working. We do need to include memory, which is where shared pointers reside in the header file. But that doesn't seem to have fixed the problem. I'm going to try building it again. Nope. Okay. Well, I better take a look at my notes here and see what's going on. Huh. Yeah, now there's shared pointers properly there in place. That's not the problem. Yeah, it's a player's a shared pointer. Make shared. Take a look at my notes again here. Let's just copy paste this in. Oh, I see what the problem is right now. Okay, make shared. Make shared is a template function. We got to tell it the type. In this case, it's player. Okay, and it'll make a shared pointer out of the player and pass that in properly. So there, our context is all set up. We've got our dungeon and our player and our context, and we're passing our context into our executive, and so everything should essentially work. It should be compilable right now. All we have to really do is go in here and start creating our command that we want to do. And let's start off with a simple one. We'll do command info, we'll call it. We'll make it a command. And all this is going to do is display some information about the user and where the user is currently at. And I'll just grab these two functions up here, copy paste them in, and fill them in properly. So we don't need that. So what do we want to do when we execute this? So it's just an info command. It's going to be, we just want to display some information about the user and maybe where the user is. So we'll just start with the user information, and maybe we'll also put in, we'll go ahead and put in the user, the player, and the room they're in, and we'll dump out the room as well. We'll display the room information. So that's just the command player being split out, and then the room. And I'm not sure if we need to say room there or not. I'm not sure if room says room when it prints out or not. But so we'll find the room because we only have the room ID. So we got to find the actual room. We can do that in Dungeon. And I think maybe we got to go write that find room function though. I don't remember if it's already in there or not. Let's look. That's our room code. Here's our dungeon code. And yeah, there's no find room. So we got to create a find room function here. Yeah, there's no find room. Okay. So we'll go over here, and I'll just copy paste it. We'll put it right here. That looks good. We'll copy paste that in. So this is our find room function. It takes an ID. It just loops through the vector, checking the ident against the ident we passed in. It either returns the room or it returns a null pointer. It's simple as that. And so this should build now, I hope. Oh, I forgot a semicolon. There we go. Put a semicolon in. And quick try build it. Make sure it's okay. Yeah, it looks like it's okay. There it goes. Yeah, it builds. All right. Yeah, there's just some warnings. They're not a big deal right now. We'll clean them up at some point in time, any warnings that it produces. It is important to pay attention to warnings and at least analyze them, see what they are. But for the moment, I just want to get the thing working functionally, and we'll worry about that later. So here we are in our in our Lexer code. So we got to create a keyword info. We'll just make it info. So that'll be the command keyword for getting info about yourself and where you are and so forth. And so here's info, and we will just return the token, and we'll call it tinfo. That'll be our token. All right. So over in the parser, we need to create the token, tinfo. And then down here under command, right under quit, we can put a pipe to separate them off. So it'll be tinfo. And so what are we going to do on tinfo? We're going to go nodes.push back new command info. And it takes no parameters. It doesn't need any details. It's got it all. And so we can do a make, and it should actually work now. Let's run .game slant game .slant game slant game .slant my dungeon, and we'll enter our name. And there we are. We're in the dungeon. If we type info, we get the info. It's the command runs. It spits out. There's our player name, Bill. The room we're in is lobby, because that's what we kind of hard coded and all that. So that is fundamentally working. And yeah, we can just type quit. Our quit command still works. So we're pulling this together. We got this, the bits and pieces coming together, the command coming together with the command loop, along with our new structure of our dungeon. Of course, we can't move around in it right now, and we'll do that later. Also, I think what we'll do here is maybe change the command prompt up a little bit. Real quick, just to show that we do have that context in here. So what this is going to do is it's going to print the prompt, but the prompt is now going to be the player name, and the room that you're currently in will be part of the prompt. So we'll build that and run it. Enter our name. And there we are, Bill Lobby is our prompt. And if we type info, there it is. So there, the context stuff is working, and we're definitely getting our name through the system and the current start room. Now the start room, we will need to have that be part really of our configuration file or our dungeon creation file. We need to stay what the start room is. We don't want to have it hard coded here. And that's just part of the language I kind of forgot about or didn't think about at the time. So yeah, we've got this just about together now. We've got the context with the dungeon and the player in it. So everything's coming together. Let's see here. Just take a look at some things. Make sure there isn't anything else I have to do. Yeah, that's our printout method. All looks good. We might want to change this up in the future, make it look a little bit nicer, but that'll be okay. So yep, everything's looking good. So I think everything's coming back correctly. We've got our rooms coming back correctly. So anyway, I think that's it for this video. If you liked the video, hit that like button. If you really liked it, hit that subscribe button. And I will see you in the next video. Thanks for watching.